So real quickly, to get started, I wanted to just kind of go back and say, what did we do before we did everything, as we like to call it, gpuCI? So I'm head of Chief of Operations of Rapids. If you want to know more about Rapids, we've got a booth out there, but then also you can go to rapids.ai. It's how we're trying to accelerate, take machine learning end-to-end with ETL and everything else. How can you do all of that data processing on a GPU and make it faster? But to do that, we also need to make sure that we're testing the code, making sure that's reliable, and try to keep it up to the standards that any other CPU-based project would be. For Rapids, back in the day, started with like Stan and Sue under a project called GPU Open Analytics, or GoAI. And it wasn't really ideal, but we only had 2 repos and a few developers, so we kind of like muddled our way through it. You know, anytime you had a PR, they weren't very many that were happening when you have a few core developers. They're just kind of doing testing, going as they go. But when you start running into this thing of this build matrix, you know, in different GPUs, operating systems, CUDA drivers, it obviously blows up pretty quickly. And trying to get everyone to do that manually was kind of like a runaround and like tag, did you do it on your GPU? Oh, does it work? Okay, then I guess it's all right, we'll put it in there. So the problem with that was, it worked for us, but the consistency and everything else, and like the quality of the code that we're getting wasn't really what we would want, especially, you know, for the alpha project that it was good, but if we were trying to build it in something else, we needed to up our game. And so with all of this manual build, test steps and that kind of stuff, we had a situation where it was great for the 2 repo project, but like I was saying, you know, proper automation is definitely needed. So first stop, we started with Travis CI. Travis met a lot of our needs because basically we were trying to just build conda packages, right? We wanted to be able to distribute this to the world and other developers instead of saying, here's the Git repo, you check it out, you build this convoluted thing that involves C, CUDA, and also Python to get it to work. Here, why don't we just give you a conda package, you can install it into your environment, do you know, import, back then it was called PyGDF, and just go about your business and have fun with it. The only problem we started running into was there's no GPU support in Conda. So like we're trying to do testing and that kind of stuff. We're still doing that manual process. We're still waiting to see like the devs that were on the team, did they all run it on their individual workstations and their types of GPU and operating system to see if everything was okay. So we're still kind of, we're moving in the right direction, but not necessarily there yet. And, you know, a little bit of a pun here, Travis city limits, right? But like, the problem is we have 5 slots. Every single time that one person submitted one PR, they occupied 80% of the pipeline. So at some point, somebody's really getting screwed over here. And like sometimes it took hours just for you to kind of get any sort of feedback to say, hey, did you actually get across the build matrix? And this is just on the Conda side. This is not even saying like, do you pass the test on a GPU? This is just, does your stuff build and can it be packaged for Conda? So like, obviously, lots of coffee breaks and that kind of stuff. One of my coworkers, he actually made a thing about the life of a data scientist. If you're working on CPUs, you actually take lots of coffee breaks because you're always waiting for something. And hopefully with Rapids, you can actually switch to decaf or drink less. Just wanted to kind of like walk through like what is gpuCI currently doing. The bottom layer we use is Jenkins. The main reason we're doing that is because also internally to NVIDIA, there's a lot of different projects that use a lot of different legacy systems from Perforce. We also use GitLab. Like, so trying to go to a cloud-hosted solution, whether it's public-facing or not, we needed this kind of, we are standardizing around Jenkins just because it can talk to pretty much anything, and anything can talk to it fairly easily. So on top of that base layer of Jenkins, we've got a couple of plugins. The one that I'm going to talk about a little bit from now is the NVIDIA remote Docker plugin, and that's something that released last 2 or 3 weeks ago at GTC, and it's the actual plugin that we use to be able to allow us to do mapping of jobs in Jenkins through the NVIDIA Docker runtime, so you can actually run all of the GPU tests and that kind of stuff in a Docker container, and it makes things really easy. The other 2 that we kind of rely on, are like the GitHub pull request trigger. So basically that's just somebody goes into GitHub, Rapids is hosted on GitHub, and all of our development work is done up there. So when any one of the developers, either on our team or externally, wants to submit a PR, all of the testing goes through here. So we rely on that plugin just to kind of trigger the appropriate jobs. And then finally is the cloud provider plugin. So that one is just whichever cloud provider that we're using for the CPU side of things, how do we like burst out? And the only distinction that I want to make on the side is one of the things that we've recently changed how we're doing is gpuCI is we actually separated out where the CPU only builds are, and that's up in the cloud, to where the NVIDIA GPUs are. So the NVIDIA GPUs we actually host locally in a like DMZ area, and they are actually give us the flexibility of having much more coverage as far as the GPU types than we would be able in the cloud. So we can have all of these different ones that allow us to do that larger matrix testing that we want to do because that's what our customers are on and the people that would be using Rapids, instead of being just saying, oh, this particular cloud provider only has this GPU or this one, and then trying to like spread out between the cloud providers. Not to mention, it is kind of expensive to get GPUs on the cloud, or you just have to compete for them because they're in such high demand. So real quickly, basically we rely on webhooks from GitHub. So this Jenkins instance in particular, I'll show it to you in a little bit. It's publicly facing, so we're able to use the webhooks to do ahead and do that plugin request trigger. Once that comes in, Jenkins then fires off two kind of separate jobs. One on the CPU only side, and that does all the conda builds. So that's where we're going through. We're saying, does this actually get to a conda package? There's no linking problems. There's no problems doing any of the types of the build. And then on the other side is the GPU testing. So does it actually test on the GPU? Can we actually pass all the unit tests that we have? And if so, all of that comes back into the PR, and you see everything in line with the PR. So this is kind of like a different breakdown. So I mean, I talked about Travis before, and when we did the shift to gpuCI, we kind of wanted to quickly replace Travis because at the time we were growing very fast. Like, you know, you go from a team of 2 developers to like 20, and dealing with that pipeline issue and that kind of stuff was like really slowing us down. We wanted also to be able to scale the builds so we could do stuff where we could burst out and not be constrained by those 5 pipeline jobs. So now like we can scale up to like 48, 60, whatever, you know, dynamically the CPU nodes that we need to be able to address all the different types of the conda builds, and then also convert the jobs to use configuration as code. So that way we'd be in a situation where the developers have more control over what's going on over the build process. And since they're the ones that are, you know, adding the new features, changing things, they are much more aware of what's going on for the build environment and when they introduce new dependencies and that kind of stuff than the operations team is. I mean, we can go back and triage things and be like, hey, what happened here? But if we can put it in the hands of developers, they're more likely to update it like as they go. So one of the things that kind of touched on was just the CPU side. It's kind of split where the CPU ones we're only doing the conda builds on, and then on the GPU side we actually do a full source build and the GPU testing. I'll talk to you in a little bit about how we're trying to make this a little bit more streamlined in the future, but it was definitely allows us to kind of do some things that we weren't able to do previously. And this was the plugin, and you can kind of get it from the Jenkins CI GitHub pull request plugin, but it's pretty easy to kind of set up. You just have to kind of have a bot user unless you want, you know, like Joe from operations, his face on everything of saying your job failed or anything like that. And it's really easy to kind of like configure not only from the pipeline side, so if you want to do it programmatically, you can do it, or if you're a smaller project and you're just like, I need to get like a GUI and check some boxes, it's very easy to do there as well. Pretty much like the 3 boxes that you check here that I have kind of like snapshotted out is basically all you need to do to like turn it on for this one. And then if you're on GitLab, they also have their own one. So internally at NVIDIA, we also have GitLab. So our internal Jenkins uses the GitLab version while our external one uses the GitHub one. And what's really nice is you kind of get like this feedback where if you've ever looked at any of the Rapids projects, you see all this stuff in line. So as I'm a developer, I'm going through, I'm getting constant feedback of how my builds are doing. Are the builds passing for conda? Are they failing for the GPU side? So on and so forth, and it allows the maintainers also to have better confidence when they go to hit that merge button. So with that, This is just like, let me make this a little bigger. This is just a kind of like an example of one of the ones we recently did where it was a hotfix that we had to put in for QDF. This ended up being version 06.1. But like every step of the way, we can kind of see these check marks that even if I want to drill in here, I can see all the tests that had run from gpuCI, easily go into any one of those to then just find out the full stack trace. I can see the full log, basically exactly what you get kind of in Travis. So it made things a lot easier for the developers that were already there to move over. They got the same expectations, and it was just kind of like a natural progression for them to move. The only thing that is a little different, if I just go back, a little different is we've added some of the extended things, like we'll actually, this one, especially since it's where we're merging into master. So instead of us merging into one of our development branches, we're merging into master. And by doing so, we want to make sure that the pip builds are actually going to work too. So we can add these custom triggers, and then also things like, is a change log updated, there also does it pass the style checks and everything like that, all in line at the same time. So our Docker plugin is open source, like I said. It's very straightforward and easy to use. There was another one that we were trying to fork off last year, and I was trying to add the capabilities to, but kept running into these weird nuances and problems with it. So we ended up rewriting this. A colleague of mine, Ray Douglas, did an excellent job on getting this rewritten for us, and has a bunch of, it's got the GUI interface, so you can kind of go through here, say, do I want it from a Docker file? Do I want it from a Docker image? So then I could just go through and give it the path, and it will go ahead and pull that down every single time. Specify the build arguments. Do you want to force pull and all these other stuff? And it works really well, excuse me. But I would say the biggest thing are the NVIDIA features that are built into it. So it piggybacks off of, if you're doing GPU development work and you're not using NVIDIA Docker's runtime, please do that. That makes your life so much easier. Because then you can abstract and do so many, you can run all these different versions. And the limitation basically with that is you just have to have the highest version of CUDA that you want to support and test with. Once you have that in place, then you can go down as low as you want with all the different images. And by having those images, it really makes it easier for you to then be confident in what you're deploying, because most people ship out Docker containers, but then it also makes it a lot easier to do that matrix build and testing, because then all of your dependencies and everything else are self-contained there, instead of it potentially being build remnants from something else that is on a bare metal machine. With that, I would say the big key thing for this plugin, and what's been helpful for us, is especially if you're in the cloud or you have a development machine in your lab or something like that you're trying to run some of these jobs on. One of the biggest problems is scheduling, right? Because you have 8 GPUs. If you just run, then each Docker container is going to see all 8 GPUs, and they all will default to GPU 0. They all try to request resources, and things blow up pretty easily. But with this, if you select executor, and then you join this to Jenkins as a node and says, there's 8 GPUs, there's 8 executors to run on there. Based on the slot that it gets, the plugin will then say, okay, the GPU assignment is automatically based off of the executor, so everyone basically gets their isolated GPU. And it makes things a lot easier instead of trying to hack a bunch of shell scripts together and everything else, which you can do for one job, as this is from experience, you can do for one job, it works really well, but when somebody else's job runs and they don't do the same thing, you still have contention. And this is kind of the foolproof way to make sure that if you are doing testing and that kind of stuff, you get an isolated GPU and it's not going to go be used by anyone else. And then with that, we also have the other things where you can, this was a nice feature that was of the other Docker Slaves plugin, I think is what it was called, of where you could actually do side containers. So one of the things that we've used in the past is sometimes data sets and that kind of stuff, kind of hard to kind of shift around for testing and that kind of stuff. So one of the things that we've done in the past is we'll generate some data sets on the fly, and that will be a separate Docker container, but we run them in parallel, so then these two are networked together, they can share a volume and all that kind of stuff, allowing you to be able to kind of like get the data from the one and run the test on the other with it. So, and like, so this particular one, this is the old, like I mentioned, Go AI. This is kind of where Rapids started from. So we released the Docker plugin here. It's pretty straightforward as far as it's just a Maven project. I think you just have to do, and it's off of the Docker Slaves plugin, which is mentioned there. As far as build, it's pretty, I think it's MVM HPI :HPI, which I should add that to the README. But once you have that HPI module, it's very easy to install into Jenkins and get it up and running. And I think as a part of some of the release stuff, it's actually there already built for you. So that was one, excuse me. That was one of the things that Ray added 14 days ago. So that way you don't even have to build it yourself. But we want people to like file issues and that kind of stuff here. If you find something that's like missing, definitely let us know, because that's the only way, like we might be using it in one way and everything is going fine, but we definitely would like to get some feedback from others as well. But like I talked about before, if I'm not empowering the developers to do this, then I'm just making my tech debt and my team's tech debt worse, because then I got to go find everything and hunt down to find out what's happening. So this is where the configuration as a code comes in. So two parts of this are, one is everything I showed you in the GUI for that plugin, we can actually do and script out in something called dynamic DSL. So it's like this language, or there's a plugin for it in Jenkins, but it allows you to kind of fully script all of this stuff out. So all of the same tick boxes, all of the things that I'm going to do on the Jenkins side, graphically, now I can actually put it into code. And then with this, I can take a couple steps further. And especially if I'm doing, especially like what we do with Rapids, where we have kind of the same matrix for a lot of the libraries that we have, we'll actually go through and repeat the same kind of testing. So we'll want to set up the same configurations, we want to set up the same jobs, and this allows us to do that instead of having to like copy and paste a bunch of Jenkins things. Then it's like, well, crap, did I like update this one? And is that like, and it quickly became into this like hairball, and it wasn't very usable. So by doing it this way, we're able to use Groovy scripts and then also the job DSL plugin to actually connect in with the Docker plugin to do that. And in addition, one of the things that we've done is to make it easier for our developers to kind of be hands-on with how they do the build and the testing process. So we put, instead of putting just the Jenkins file or something like that in the repo, which can be fragile depending on what's going on, most of the build stuff, like the matrix and that kind of stuff, is pretty well defined. Like the developers shouldn't necessarily need to do that until like the entire project moves. So at least our stance on the way we have it is that's not exposed to the developers, but like this build.sh is. So it's a shell script that sits inside the repo that goes through, sets up in the environment, and triggers and kicks off all the builds for the conda side and then also for the GPU side. So they know that if they have a situation where they need to do an update on the GPU test, they can make those tests or make those changes inside of the repo. And what's really nice too is on the pull requests, it will actually use whatever script is in that pull request. So like if I'm a developer, I could iterate back and forth and get real-time feedback with the CI platform, just like you would using Travis or something else. So like we're still keeping that functionality, and then it makes things a lot easier. And just like a quick, so this is like in QDF, there's a CI folder. And if you go into CPU, there's that build.sh where we can just kind of see like, what are the things that we set up? How do we export the get described tags? And that's how we kind of like tag off and version things, and how many commits are we off from stuff. But the debugging output that we do for Python, GCC, conda, and then also how we like kick off the conda packages. And there's a certain dependency chain that we have for this particular library where we have to do them in a certain order. But anytime that the developers have run into something where they're saying like, oh, I need to change this dependency, or I need to do this, by at least having the shell scripts here, like they can easily reproduce this locally and try it locally, but then they can also confidently do the pull request just like any other code process, and we don't have to worry about like anything really breaking. So the other nice thing about this particular plugin is the Docker Slaves plugin did not support multi-configuration support, and if you're not familiar with that, basically allows you to do what that chart has, where you're trying to have like this convoluted configuration matrix where I've got 3 different versions of CUDA, 3 different operating systems, and 3 different types of GPU hardware, and I want to test everything on all of them. And this will allow you, and this plugin allows you to do that. So it's really nice because then we can just set up the same jobs, same like test scripts and all this kind of stuff, but then it gets replicated by Jenkins and taken care of like the full matrix by itself. So you can really easily get the feedback that you want without having to kind of struggle to do it yourself. The only other thing is if you are using Jenkins, like I don't know how many people do use Jenkins, but by default, for some reason, blue is success. So if you look at that, that's supposed to be they're all successful, which doesn't translate to me at all. There is a plugin called Green Balls, which is weird, but like I encourage you to install Green Balls because that's what we do. Because like if I saw that and I'm just like, oh, they haven't run yet, but that's because I'm like so used to like glowing green spheres to say like everything's a-okay. But yeah, like this was just from one of our development machines that had like a basic Jenkins install, so that's why they're not green, but definitely install that plugin. So, like just like Krusty, like how can we make gpuCI go faster? Maybe it's not speed holes, but maybe something else. So this is kind of where we started earlier, right? Where we're kind of splitting things off, CPU stuff, conda stuff on one side, GPU stuff on the other side, but self-admittedly, there's a very big waste of time on that GPU side. And that's because I'm doing a from source build just so I can get to testing. And like I mentioned earlier, GPUs are expensive. Like especially when I'm in the cloud and I only have one, and I'm running into the same pipelining problem that I would have in Travis. So to get around that is what we're working on now, is where it's a multi-staged approach. So still keep the CPU side where we go through and we do change log tests, style, all the different CUDA versions, and update those. But in between, there's this orange in the middle where we're kind of like grabbing all those artifacts. So we're not releasing anything. If this was me trying to make a release or even just doing a PR testing, like this middle artifacts part is not even something that really publicly gets exposed. It's kind of like it goes to a staging area. But what's nice about that is then I can then take those staged artifacts and then burst into my matrix testing. So just like that matrix testing of all the different stuff, those 27 combinations I want to do, now I can do that in almost the same exact time that I had where I did one from source build, one configuration test, because I'm not going through and I'm not spending all of this, because mainly what happens is I'm doing it on the previous version was I'm using the CPU on the GPU machine to do all my builds, waiting for all that to complete, and then once that's done, then doing so that like the actual time that I'm using to actually like fully utilize the GPU for what it's meant for is like very small in comparison to what I was using before. And now this way I can start bursting out and kind of like using the GPU almost like those burstable like CPU nodes that I was using of saying like, here's my matrix, go run these jobs, each of which now take like 2 or 3 minutes. So I can do many more of those versus occupying a 30 minutes run on a GPU to do the from source build in there. So with that, and then it's just kind of like also a kind of like testing, and then you promote, and then once we've passed the GPU side, then we can promote up. The other thing, the other benefit to this is by having this mechanism, we want to be able to make it easier for the developers on our team to also see, as they're doing a PR, what is the resulting conda package. We have nightlies now, and I'll talk about that a little bit later, which has been great, but the problem with a nightly is a nightly catches everything after it's been merged into the development branch. It doesn't catch anything before, like when it's on a PR. So like, if there's a problem in a conda package or something that's wrong, like that's in the PR, like there's no way for them to do it unless they run everything locally and try to build their own conda packages. So by doing this process too, this gives us an avenue that allows it to be very easy for us to make all of those conda packages available. So as we're getting close to doing that final merge from their PR over, we can just double check, make sure everything's good. Some other stuff that is just kind of on the plate, always aspirational, want to keep making things better. It's just about the time, right? So like speeding up the builds, store Docker images, in AWS instead of it being like from Docker Hub, mirroring the conda packages, because sometimes you try to go get conda packages and then get a 500 or 504 error, and then like everything breaks. The other enhanced testing stuff is kind of things that our engineers have been asking for, is like how can we add some of the profiling tools that are really native to GPUs, like CUDA memcheck and things like that, and directly integrate them into the CI platform. So we're working on trying to do that and also release those as plugins. So it's tick a box and then you have that ability instead of it just being like go write a bunch of shell script to like force it in there. I'll talk about the Kubernetes support in a second. And the lab hardware, we just actually switched over a couple weeks ago, so that definitely is now, I went from like 2 GPUs for the entire like Rapids development process to 28 now, and they're 4 types. So like obviously gives us much better test coverage and ability to do things. So with Kubernetes, like where are we headed with that? Just quickly, if you're using Kubernetes and GPUs, you definitely want to be able to take advantage of the NVIDIA Docker plugin, which is this one here. So this one allows you to kind of do the limits of NVIDIA GPU 2, so you can like actually kind of like request out. This is really good, so especially when you start going from a lot of the testing being single node, single GPU to single node, multi-GPU, and then eventually when you start integrating stuff like where plans are with like testing with Dask of saying multi-node, multi-GPU, Kubernetes is where we have to shift like some of the CI stuff. Doesn't mean everything's going to move there because like one-off builds and that kind of stuff, we're still going to use the other plugin, but this is one of the things, like the device plugin gives us capability, but there's no direct tie-in with Jenkins yet. Jenkins does have the Kubernetes plugin, and you can kind of like force insert what we saw before and kind of like, custom add this, but it's very hacky. It's not like any way that's sustainable, and like when we come to try to go script something like this, it's not going to work out very well. So that's one of the things that we just started development work on this week, and so hopefully sometime by the summer, we'll have the Kubernetes plugin out as well, also on the GoAI website, or GoAI GitHub page, to be able to address this problem here. And basically, instead of it being 2 separate clouds, we would just burst into the Kubernetes cluster, being able to target like CPU nodes versus the GPU nodes, and then also like which types of GPUs and how many GPUs we would like. So there's like nightly builds that I mentioned before, and it's been really helpful in that kind of stuff because not only does it help from being chief of ops, like I release every Rapids release and go through and work with all of our teams to get that done. The Rapids team sometimes, like we don't catch things till the end, and then like the releases kind of lag a little bit because it's just like, oh, what is this seg fault, or like what is this thing, and like, but this release around, it was actually a lot better because we actually had the nightlies in place. So the nightly started standing up as somewhat of a release candidate that were generated every single night. So that way we had lots of eyes on the problem instead of it being like, the night of the release or the day of the release being like, I've never seen that before. And they're available to everybody to use, so really easy to kind of you just replace the channel Rapids AI with Rapids AI Nightly. And the main reason we did this was just, we wanted to make it a little easier, especially since we have a lot of libraries within Rapids, like cuML depends on cuDF, right? So I want to know, does the stable version of cuDF work with the nightly version, stable version of cuML work with the nightly version of cuDF? And other libraries and that kind of stuff, they'll do where it's like cuML-nightly, cuDF-nightly, and that's a separate package, and like we decided to do separate channels because it made things a little easier so we can mix and match things for our testing to make sure that things are stable and work well. And the same thing for our Docker containers. We do a nightly Docker container. If it's not updated within 24 hours, that means something broke on our end, but we're working on it, but that's also good because that means something broke and we know about it before the release. So how do we, one of the things, if you ever talk to an NVIDIA, and they'll be like, okay, what's, our CEO, Jensen, likes to ask the question, speed of light, what is it, and how do we measure it? So one of the things that we're working on right now is airspeed velocity, is integrating with airspeed velocity, which is a Python benchmarking framework. And it's really great because you can kind of go through and you can tag with a bunch of metadata, all the different types of Python version, CUDA, hardware, GPUs, and all this information, puts it in a nice web dashboard and front end that you can go through and kind of see where the regressions are. It automatically detects all that. And the other nice thing is it will, if you say from version whatever to this version, it will test every single commit along the way automatically. So it does really good parts with that. For Python, on the C side, it's not really designed for C, so we're kind of cramming C and G tests and that kind of stuff in there because we want that visibility too. And right now it's just us writing our own custom parsers and that kind of stuff, all of which once they're ready, we'll post up onto the gpuCI GitHub as well. It's just mainly for us because that way we can centralize everything in one place and we can see, because I can go to Jenkins right now and I can see oh, this particular GPU job has all these tests. I'm like, that's great. But that doesn't really help me to actually see the full picture that I want to be able to see. So the only thing, the challenges I would say that are important to point out here is there's there's two opposing use cases from our developers. So there's two approaches to get this done. One is the benchmarking, which is end-to-end, and that means from the time that I have imported my CSV file and I went all my steps, what does that look like, versus having the same thing of granulars, that join took how many seconds or milliseconds and everything, and having both of those is a little bit different just because of how ASVs, the framework works. So trying to get both of those solved at the same time, either we'll be committing back to ASV or open sourcing the stuff that we've done. So test often, more test often, and test better. One of the things for testing is that we're trying to do is trying to combat some of the challenges and that kind of stuff where there's a testing fatigue, but as we keep growing, that kind of stuff, the testers need to grow. Try to focus away from the white box testing a little bit just because they become very expensive to maintain, where especially on an early project like this, where we have a lot of speed behind us, but there's a lot of impetus to just also break APIs, and then when you do that, a lot of these tests that are really familiar with the internals are also broken. And then the other thing is testing takes too much time. So that's the other thing I wanted to point out is just one of the things is we're working on reducing the full matrix test. So as you're doing a PR, you can quickly iterate through things, focusing on the general case, and then towards the end you focus on the specific. And that really helps kind of get through, and I got an example of that. So if I've got my little blue developer guy, he's kind of go through the test matrix. Our development branch 07 is the current one we're on. So obviously the test matrix is full. We do every single thing on those, and we do those nightlies as well to make sure there's nothing wrong. But as the user and the developer is kind of contributing, it's everything seems to be good. The first one, got a mistake, back to good. And the user starts kind of getting confident that they're ready, almost getting ready to say, let's do the full thing. So that's when one of the maintainers comes in. They're a firefighter, because basically that's what they do, fight fires for Rapids. So and then now that we've expanded the test matrix, it's oh, well, we're actually fully good on one side, but actually not the other. We can iterate again, broke everything, let's try it again. And then finally, when everything's green on this side, we can merge it in. And then, of course, on the branch side, the CI tests also try nightly, and then also on every commit that happens to make sure that those matrices, they should always match, but just in case we want to make sure because we don't want to introduce something. So, and without ops, as Josh knows, Rapids doesn't scale. So one of the things is definitely leverage the GitHub issue templates and common labels across our repos. Like, you know, we're a little unique because we have so many smaller libraries. It's not like, you know, another project where it's just like, okay, here's my one repo, everything's in that repo. Rapids right now, there's like 8 or 9 core ones, all of which have their own issues and, you know, had their own labeling and stuff. So that was definitely something we had to change pretty quickly. Some people were like, oh my gosh, no Jira, but like, definitely use the GitHub project boards. They've been very useful for us. We actually publish, if you go to docs.rapids.ai, you can actually see our development process, not only for like how we do the merges, but also how we do triaging of issues and all that kind of stuff is all documented. One of the other things that, like I was saying, like we have all these little libraries, and as they come on board, there's like this tech debt. So one of the things we did was kind of like standardizing the repo template and then also the CI process, and that's where you saw all those like shell scripts and that kind of stuff that are common across everything at the moment. So it makes it very easy that if someone's forking something and moving off, they're going to do that. The last ones is like GitHub issues are much greater than Slack. So a lot of people use Slack, but just for ops, definitely we make ours go ahead and file issues because it makes life a lot easier. So just quick lessons learned. Docker images are expensive, so we use pre-built images for our gpuCI-based environments. Be careful of like the linking stuff if you do. Like sometimes there's some hacking around techniques I can talk to you guys offline about, like on CPU onlys. Where you run the style checker like inline, so like it fails by itself, but it doesn't fail everything. In Travis, it actually would fail the whole project, which was bad. And not all metrics testing is equal, and that's kind of what we talked about in that like little example. You don't have to test everything all the time. And then also educate your devs and people on submodules. They are effective if used properly. So going to keep working on updates for the plugin. We're going to incorporate ASV into Rapids testing. The Kubernetes plugin, like I said, sometime in the summer. We look like that. And longer term, we're trying to establish more what does a gpuCI stack look like, you know, with the plugins and everything to support that type of stuff. And I'll end on this slide. So like mentioned a couple of these repos and that kind of stuff. So the NVIDIA Docker runtime, which is really great to use, is there along with the Kubernetes plugin if anyone's using Kubernetes. And then that's where you can find the Jenkins plugin with that. Any questions?